This is Maths Demystified. Latitude and longitude. A quick review of the features of the shape and formulas. Let's start with the great circle. The great circles are the longitudes. The longitudes are also called the meridian, but there is a particular latitude that has the same size as every one of the longitude, and that is the equator. So the equator is also called a great circle. So when you hear great circle, we are either dealing with the longitude or the equator. The longitude run from the north, like that, towards the south. Let me just draw this line to help us. This is the North Pole, this is the South Pole. I'm drawing the diameter of the equator. We call it 0 degree north, that's the equator. So this is my longitude. It could be towards the east, it could be towards the west. There are 360 longitudes altogether. 180 towards the east and 180 towards the west. And the one at the center is called the Greenwich meridian. So if I have 2 points on the same great circle, say I have point A here and I have another point here, maybe point B, and I want to find the distance between A and B. That's this distance. I want to find the distance between A and B. Because they are on the great circle, I will trace the point to the center of the great circle. This is the center of the great circle, and that's the center of the whole globe. So I will trace this to the center of the great circle, and this is the radius. That's my capital R for radius of the great circle. So this one becomes the distance I'm looking for, and there's an angle here called the angle theta. Let's call this point. Let's assume that the point is on a latitude. Let's call that latitude here 60 degree towards north. This is the 0 towards north, 60 degree. Let's call the latitude in this place 50 degree, it's towards south. So to be able to find the angular difference here, we are going to add. Why? Because this is 0 degree, 60 is towards north, and 50 is towards south. So, and we're going to combine the two of them together. So we are adding. If the two of them were on the same side, say this 50 is somewhere here, and the distance is just like this. They are on the same side of the pole, 60 degree north and 50 degree north. I will subtract to get theta. And when they are on different side of the pole, I will add to get theta. So in this case, my theta is equal to 60 plus 50, and that will give me 110. 110, and that's my theta. Now I'm looking for this D, and if you look at this shape properly, you will discover that it is a sector. So the D I'm actually looking for is the length of the arc of this sector. So the D, we have the same formula as the length of the arc of a sector, which happens to be theta over 360 2 pi r. As simple as that. Where this theta is the angular difference and pi is 22 over 7, and the r here is the distance of the radius of the earth, which is approximately 6,400 kilometers. So if I substitute the values I have, that will give me 110 over 360 times 2 times 22 over 7 times 6400, and I will calculate. And that will give me 12292.06 kilometer. It's as simple as that. Let's assume that I have my equator and I have 2 points, point X and another point Y, the two of them are on the same equator but on different longitudes. Say longitude of X is 20 degrees east and longitude of Y is 50 degrees east. They are on the same side of the pole. The 2 points are on a great circle. Like I told us, I will trace the point to the center of the great circle, trace the second one to the center of the great circle. This is the distance I am looking for. I call it D. This one is my capital R, this is another capital R, this is the theta, the angular difference. In this case, my theta will be the difference between these numbers. Why? Because they are on the same side of the pole. So in this case, my theta is equal to 50 degrees minus 20 degrees, which happens to be 30 degrees. And this is still a sector. It is still a sector. So the D will now be equal to theta over 360 2 pi capital R. Why? Because I'm dealing with great circle. Then my theta is now 30 over 360 times 2 times 22 over 7 times 6400. Answer is 3352.38 kilometers. In summary, when the 2 points are on the same great circle and you want to find the distance between the points, you trace to the center of the great circle. In this case, the distance between A and B, they are both on the equator, are traced to the center of the great circle. And this is my R, this will be my R, this will be my theta, this is my distance. If I want to find the distance between B and C, they are also on the great circle. I will trace to the center of the great circle. This one is already traced, this also, and that's my theta. So this will be my distance. And the formula will be D equals theta over 360 2 pi R. The same formula for calculating the length of an arc. Now to small circles. Small circles are referred to as latitudes. All of them are called latitudes. Now they are also often referred to as parallel of latitudes because of the way they are arranged. They are all arranged in parallels. And you see in the parallel, they all form circles. Circles like that, circles like that. And even the equator is one of them. But the equator is the largest. So we have taken it out of them and we are now calling it a great circle. But aside the equator, others are called parallel of latitudes. Now, let me draw the equator here. This is the diameter of the equator, 0 degree north. So the equator is, here's the equator. Right. So other latitudes are arranged towards the north and towards the south. There are 180 parallel of latitudes altogether. We have 90 towards the north and we have 90 towards the south. When 2 points are on the same latitude, say we have a latitude here, let's call this 70 degree north. Assume that we have a latitude here that is 70 degree. And we have 2 points on the latitude, say A, and we have another one here, B. If this latitude here is, is towards the west, let's say it's 40 degree towards the west, and let's assume that this one is 30 degree towards the east. And I want to find the distance between the A and B along the latitude. The other ones we did was along the great circle. So this one along the latitude. When we're doing it along great circle, we trace this point to the center of the great circle. But now, along the latitude or along the small circle, you trace to the center of the small circle. We use capital letters for the radius of the great circle. We use small letters for the radius of the latitude. And the angle here, I don't want to call it theta, let me call it alpha to be able to distinguish them. And this is still my D. So looking at this properly, you see that we're supposed to use exactly the same formula to find this. So the formula to find it, now in this case, if I want to find my alpha, looking at alpha is the angular difference, and you see that they are on different sides of the pole. What am I going to do? I'm going to add. If the A and B are both on west, or east, I will have to subtract, and that will give me 10. But in this case, they are on different sides, so that will give me 40 plus 30 degrees, and that will give me 70 degrees. So I'm going to be using 70 degrees for my alpha. So my formula will be alpha over 360 2 pi, not capital now, small r. But my small r happened to be, I'll show you in a minute, 2 pi. The small r is capital R cos, let me say beta. I'll show us how they derived the capital R cos beta later. But let's continue solving. Where this, my alpha, is my angular difference, then this one is 22/7, this is the radius of the earth, 6400, and this b here that you have is the given latitude, which is 70. So I have my distance to now be equal to 70 in this case over 360 times 2 times 22/7 times 6400, then cos 70 degrees. And the answer is 2675.36 kilometers. I want to explain to us how they got R to be equal to capital R cos beta. I said the beta is the given latitude. So if my beta is here, that's the given latitude. Now, from here, this beta, how did they get the beta? I'll show you. If I draw a line here to this place, that is the radius of the earth, capital R. You know, I'm drawing it to the center of the circle. That's capital R. The angle here is what we call beta. The angle is what we call beta. So this is raised beta angle to this place. That's the angle. So if the angle is beta, it means that this place too is beta, because these are called parallel of latitude. They are parallel to themselves. So this is beta, this is beta, this is my R. And from here, anywhere, any point on this, if you trace it to the center of the latitude, it is a small r. So this one is my small r. From here to here is my small r. From this point to this point is my small r. From here to here is my capital R. This angle you see here is this angle here. And they are alternate to themselves. So looking at it critically, if I want to find this, you know, this one is adjacent to this angle, and this one is hypotenuse because it's 90 degrees. So that my cos beta will be equal to R over capital R. Hence, my small r will now be equal to R cos beta. That is how we got the formula. Yeah, there's something else I want to show us very quickly because it will be needed towards the end of the lesson. Sometimes we'll be asked to find this chord. You know, this is a circle, it's a real circle. So the line joining from here to this place, the straight line joining inside, that's a chord. Now this is a circle, so if I draw it, this part is a segment now. So if I want to find this line here, and if I trace this to the center of the latitude, and this happens to be small r, and this is also small r, and here we have said we want to use alpha, and I'm asked to find this line here, not the curve, not this curve, not this distance, but this line. I want to find this line that is here. What do? I decided to bring out this circle so that we can properly see what is happening. This circle is this A is this place, this B is this place, this distance is this one, but the line I'm talking about is this line. So we have called this one R, we have called this one R. So the angle here is alpha. If I divide this into two equal parts, this will be 90 degrees. If you can remember the theorem, 90 degrees. So this will be alpha over 2. This one to be alpha over 2. And I'm looking for distance between A and B, the straight line between A and B. So let me call this place D1. This one too will be D1. So 2D1 will be AB. That is D1 plus D1 will give me 2D1. And that is what AB is. So first thing I want to do is to get D1. When I get D1, I'll multiply by 2. That will be my AB. Let's get to it. So looking at this triangle, I want to bring the triangle out for you to see. This is the triangle. This is alpha over 2. This is R. This 90 degree, this is D1. So this is opposite over hypotenuse, and that is sine. And that will give me sine of alpha over 2 equals D1 over R. And I'm looking for D1. I'll simply make D1 the subject of the formula. So my D1 is equal to R sine alpha over 2. That's what my D1 is. Now, my AB, the line AB, will now be equal to 2D1, which will now be equal to 2 small r sine alpha over 2. We have seen that small r is equal to capital R cos beta, where the beta is given latitude, sine alpha over 2. You will need this formula later. Please master it very well. So anytime we are looking for the chord, anytime we are looking for this chord, just know that this is the formula that you need to use for this chord. We just got to one of the most critical parts of this topic, and I want everybody to pay attention to this. Let's look at this diagram carefully. These 2 points are on the same latitude. Let me call the latitude beta. We are used to it now. The 2 points are on the same latitude beta. If I want to find the distance between A and B along the latitude, this is the part. I will trace this to the center, and I will trace this to the center of the circle. I call it small r, call it small r. This is my alpha. I will use D equals alpha over 360 2 pi r cos my given beta. And this is the distance I'm dealing with. This distance I'm dealing with. But sometimes they can ask us to find the distance of A and B along great circle. When they ask us to find distance along great circle, we trace to the center of the great circle. We have capital R. Center of the great circle, we have another capital R. This will be the angular difference, and we have been using theta. I don't want to change it. That's theta. So now, where is the root? This is the place. There's going to be another curve coming like this, and that will take us to this place like that. Long great circle. So the distance will be from here to here. I hope you got that. I will repeat myself. I have 2 points A and B, and they are both on the same latitude. When they ask me to calculate the distance along the latitude, this is the distance they are talking about. I will trace to the center of the latitude, and I will use this formula. But when they say I should calculate the distance along great circle, this is the distance they are talking about, the one in red they're talking about. I will trace to the center of the equator of the great circle. I will label it RR. This is my new D now that I'm looking for. So this my D that I'm looking for, it will be adjusted to 2 arc sine alpha over 2 cos beta. This whole thing you see here is representing the angular difference. I will show us how they got this immediately after this. So this is representing this. And you know that when you are dealing with distance between 2 points along great circle, we always use theta over 360 2 pi capital R. So this is now my theta over 360 2 pi r. The formula has not changed. The theta had only been adjusted. Let me show you how we got this so you can appreciate it. Now, I'm bringing you back to this diagram that we drew earlier, that we used to find the formula for calculating the chord. So this same chord here is what we still need. So let's trace this to the center here and trace this to the center here. This is what I call theta now. this is my capital R, and this is my capital R. I want to bring out this triangle. No, this is a chord now. So I want to bring out the triangle. If I bring out the triangle, I will have where this is capital R, capital R. If I divide this so that this whole thing, we got it the other time to be this, but from the half of it, we got to be this. We got half of it D1. We call this, in this diagram, we call this D1. This line is what we have here now. This line here. So we call this D1. So this is the D1. This part is what I need, D1. And the D1 is this. And this R you see here is R cos beta. So this R cos beta, then sine alpha over 2. I hope I'm not too fast. Let me go back. This line that you have is this line. This D1 is this D1. And R is capital R cos beta. That is capital R cos beta. Then sine alpha over 2. So let me get back here. So the whole of this is theta. So this part alone is theta over 2. So using trig ratio, this opposite over hypotenuse, that will give me sine will be equal to R cos beta sine alpha over 2 over R, opposite over hypotenuse. So this R has cancelled this R. So I am looking for theta. So arc sine theta over 2 will now be arc sine cos beta sine alpha over 2. Now, since it is theta I'm looking for, theta will now be equal to 2 arc sine cos beta sine alpha over 2. Please note this. Theta is now 2 arc sine cos beta sine alpha over 2. That's what I wrote as 2 arc sine sine alpha over 2 cos beta. Welcome back to this diagram. We have done a lot. Sorry about all that. So we are saying that for us to get this theta, it is 2 arc sine sine alpha over 2 cos beta. So the whole of this is representing the theta, then 360, then 2 pi r. So it is see the same thing as theta over 360, 2 pi r. The theta had only been adjusted so that we can calculate it. Don't forget that this alpha here is the angle here. Angle up here is the alpha you have here. So in general, when you have 2 points on the same great circle, which means 2 points that are both on the same longitude or the same equator, you want to find the distance between them, you use d equals theta over 360 2 pi capital R, because they are on a great circle. And that is the only formula you use when the 2 points are on a great circle. Now, when the 2 points are on the same latitude, you have to be careful to read the question properly. And now check along what route are you calculating the distance. So if you are calculating the distance along the latitude, you use d equals alpha over 360 2 pi capital R cos beta, where beta is the given latitude. But when the 2 points are on the same latitude and they are saying find the distance along great circle, you use d equals, can you remember it now? Yeah, d equals 2 arc sine alpha over 2 cos beta, everything here is representing theta, over 360 2 pi, capital R. These two are always confusing. So you need to know when to use this and when to use this. I will label this 1, and I will label this 2, and I will label this 3, and I'll give us a quiz very soon. Number 4, when the 2 points are on the same latitude and you are looking for the chord, the length of the chord joining them. If you can remember, we said the length of the chord will be 2r sine alpha over 2 cos theta. These 4, we need to master them properly. There's one more thing I want you to note. When the 2 points are on the same latitude and you are asked to calculate the distance along the latitude, and the second question is saying calculate the distance along the great circle, the answer you get along the great circle will always be the shorter distance. Please note, the distance along the great circle is always a shorter distance compared to that along the latitude. Don't forget, when the 2 points are on the same latitude and you calculate, the distance along the great circle is always shorter than the distance along the latitude. So in this case, this distance you see here is shorter than this distance here. Indeed, any 2 points on the surface of the earth lie on a great circle. If you will agree with me, any 2 points on the earth's surface lie on a great circle. Of course, when we started, we said 2 points on the same great circle. So they are both on the great circle. Maybe the two of them are on the same longitude or they are on the same equator. And we came here, we said when they are on the same latitude. And we also said we could also calculate along great circle. So that simply means that any 2 points on the surface of the earth lie on a great circle. Now, here is my quiz. I will tick the correct answer as I ask you the question. This is the formula number 1, formula number 2, formula number 3, formula number 4. When I ask a question, I will tick the correct one. When 2 points are on the same great circle, say the 2 points are on the same equator, and you want to find the distance between them, which formula will you use? You have to be very fast. This. When 2 points are on the same latitude, I want to find the distance between the 2 points along the pile of latitude. Number what? Fine, number 2. When the 2 points are on the same latitude and you want to find the distance between them along great circle, which one do you use? Beautiful. When the 2 points are on the same latitude and you want to find the distance of the chord joining the 2 points, which one do you use? Beautiful. I think you can clap for yourself there. Now, the last one. If the 2 points are on the same latitude, and the question just says, find the shorter distance. Which one do you pick? Be careful now. Shorter distance. Beautiful. I've told us the distance along great circle is always the shorter distance. Thank you for viewing my channel. And please do not forget to click like and subscribe to our YouTube channel so that you can get more information on any other topic. Thank you and God bless.